Hello, second grade scientists. Welcome back to Science with Mrs. Miller. Today we will be exploring the property of absorbency. Ooh, boy, that's a fancy science word. Can you say that word with me? Ready? Absorbency. Now say it a little bit faster. Absorbency. What does it mean if something is absorbent? Have you ever heard that word before? I know what you're thinking. Perhaps you're thinking, I know I've heard that word, I'm not sure where. Well, maybe you heard it when you were listening to this commercial about Bounty paper towels or any other paper towels for that matter. So to refresh your memory, click on the blue button to hear how the advertiser for Bounty paper towels uses the word absorbent. Pause this video here and then click on the blue button up in the top right hand corner. See you back in a minute. Welcome back. Did you recognize that commercial? You might have seen it on TV before. So after watching that commercial, use your context clues. What do you think that word absorbent could mean? Whisper what you think is the definition of absorbent into your hands right now. 1, 2, 3, eyes on me. Okay, so here's what I said. I wonder if you said something similar. I said the word absorbent talks about, it means like how much water something is able to soak up. Something that's very absorbent can soak up a lot of liquid. So absorbency is another property of matter. When a material is absorbent, it is able to soak up and hold water inside of it. Let's think of some examples. Well, we already know one example is paper towels. Paper towels are built to be absorbent. They are built to clean up spills and to absorb water. Can you think of some other examples of other objects or materials that are also absorbent? Go ahead and name them across your fingers. See how many you can name. Ready, set, go. One, two, three, eyes on me. Let's see if you came up with any of the examples I came up with. A sponge. Yes, a sponge is made to be absorbent. It's made to soak up water. That's why we use it to clean our dishes. A washcloth. That's right. We use a washcloth to clean our body because it absorbs water. A towel. And then after we wash our body or maybe our face with a washcloth, we might use a towel to dry ourselves because a towel absorbs liquid very well. And last but not least, a napkin. Yeah, a napkin absorbs liquid as well. Perhaps not as well as all of these other items, but it does absorb liquid too. When a material does not hold water, we say that it repels water. Say the word repel. Repel. That's right, repel. Sometimes we call those materials that repel water waterproof. Let's think of some examples. I'll give you one. A raincoat. A raincoat repels water or repels liquid. It's built that way. Why? What's the purpose of that? That's right. Yeah, it keeps you dry. If you're out in a rainstorm, you have a raincoat on, your body will stay dry because the raincoat repels rain. It repels any liquid. So let's think of some other examples. Go ahead and name them across your fingers. Ready, set, go. One, two, three, eyes on me. Let's see if you came up with any of these other examples. An umbrella. Raise your hand if you thought of an umbrella. Yeah, an umbrella is built with the purpose of repelling water to keep you dry in the rain. A car, the outside of a car, the body of a car is built to repel water. Have you ever looked at a car after it's rained and you see little beads of water on it? That's because the water, the liquid, did not absorb into the car itself. Instead, it drips off. Ooh, a ski boot. Very important that a ski boot repels water. If you're skiing and your feet get wet, you will not be a very happy camper. You'll feel pretty miserable to have cold, wet feet while you're skiing. So it's a good thing that ski boots are meant to repel liquid. All right, it's time to hear from our friend Dr. Jeff again. I wonder what he will have to say about this topic of absorbency. Let's listen.
Now for our final property, we're going to learn about absorbency.
What's that?
Absorbency is a material's ability to soak up water like a sponge. Here is a pitcher of orange juice. To test how absorbent something is, we have to see how well it can soak up this liquid. Let's try soaking up this mess with 3 different materials. Addison, why don't you try the foil first?
The foil isn't soaking up anything.
EJ, you can try the sheet of paper.
The paper only soaks up a little bit.
This time, I'm going to try the towel.
Whoa, the towel soaks up a lot.
So what does this tell us about the absorbency of these different materials?
The towel soaked up the most liquid, so it's the most absorbent. And the paper soaked up a little bit of liquid, but not as much as the towel did, so it's less absorbent.
And the foil didn't soak up any liquid, so it's
The least absorbent.
correct. Absorbency is important when you need to dry things, like after a swim or a car wash. And materials that don't absorb water are useful for making things that should be waterproof, like a rain jacket. Now it's time.
So in that video, that Generation Genius video with Dr. Jeff, he showed us, along with his lab assistants, they showed us how we can look at different materials to determine which is more or less absorbent. But how can we prove that? Like EJ here, he said that the paper didn't absorb as much as the towel. Now, we might have been able to observe that with our eyes, but how could we prove that? Because remember, scientists, they say, I like to prove it, prove it. I like to prove it, prove it. I like to prove it, prove it. I like to prove it. So we need to figure out a way to prove it. How could we prove it? I want you to think. And then I want you to whisper what you're thinking to somebody near you. If you're at home, whisper to a family member or someone else in your house or your imaginary science partner. If you're in school, I want you to tell somebody near you. Okay? Actually, you won't be able to whisper through your mask. So just tell somebody near you what you're thinking. How could we prove which material is more absorbent? Ready, set, you have 10 seconds. Turn and talk. Time is up. I wonder if you came up with the same idea as me. Did anybody think Perhaps we could try soaking up water with different materials, and then we could measure how much water was soaked up. Then we could compare the different amounts. That would tell us for sure. That would prove which material is most or least absorbent. Good thinking, scientists. Let's get to it. All right, today we are going to be like grown-up scientists. Do you remember how we did a lab report way back when? That lab report was on the attributes of gas. Remember doing that? Yeah, that was a lot of fun and it really got our brains thinking. So today we're going to exercise our brains in the same way using yet another lab report. Oh my gosh, are you ready to grow your science brains like crazy? I can feel mine growing already. So if you're at home, find this sheet in your Google Classroom. If you're in school, your teacher will give it to you. Actually, it's not a sheet. It's a packet. It's our science lab. So the scientific process always starts out with a problem. What is this problem? The problem is always what we're trying to find out. And what we're trying to find out is which material is the most absorbent. Here are the materials we'll be exploring: wax paper, paper towel, or a sponge. Now our hypothesis. What do I think and why do I think this? Think about that. I can't tell you the answer here. You have to come up with it on your own. Which material do you think is most absorbent and why? How do you know that? What makes you think that? Go ahead and write down your hypothesis. Pause the video here while you write it, and then unpause it once you're done. And remember, your hypothesis should start out with I think, and then you'll say what you think. I think, da-da-da-da-da-da. Okay, welcome back. I wrote my hypothesis. Thumbs up if you wrote yours. Awesome sauce. If you didn't, pause again. Make sure that you write yours. I'll share mine with you. Maybe it'll get those wheels turning. This is what I wrote. I think the paper towel will be most absorbent. I think this because it is meant to clean up spills. Oh my goodness, I just realized something serious. I forgot to do something. What did I forget to do? I forgot to write my name. That's always supposed to be the first thing I do. I'm going to do that now. Okay, if you haven't finished writing your hypothesis, finish it now. Once you're done, you can come back to this video and we'll go on to our next step. Okay, so now on to the procedure. In this space, later on, not right now, because we want to make sure that we have enough time to get to this activity. So later on, you'll draw a picture of yourself doing the experiment. If you're not able to do this experiment for any reason, you'll draw a picture of me doing the experiment. Okay, now it says, what do I need? Wax paper, paper towel, sponge, a tub of water, a graduated cylinder, or a measuring cup. Can I add that there? I'll add it in on yours. Or a measuring cup. And a funnel if you're using a graduated cylinder. Okay, what will I do? It says use sequencing words in the steps. Here are the steps. I've written them out for you. So we just have to follow them precisely the way that they're written. Step 1, dip the paper towel in the water. Step 2, next, let the extra water drip off, then squeeze the water into the graduated cylinder or measuring cup using the funnel if you're using a graduated cylinder. Record your results. Repeat steps 1 through 3 using the wax paper. Finally, repeat steps 1 through 3 using the sponge. Okay, and then let's turn to this side. This is where we will record our observation and results. So we're going to graph our results on this sheet. And then we'll write about 2 things that we observed during this experiment. All right, so the first material that we'll need is our paper towel. I have my paper towel here. I have my water. I've colored it blue just to make it easier to see. If you're doing this at home, you don't need to color it because you'll be able to see it easily. You'll also need, like I said, a graduated cylinder or a measuring cup. Now your measuring cup has to have milliliters on it because that's what we'll be using to graph our results. Okay, so I'm going to take my paper towel here. I'm putting it into the water. I'm going to soak it all the way. Then, as the directions say, as the procedure says, I'm going to let it drip. Let any excess water drip off. Okay, now I need to measure it. So I'm going to wring it into my measuring cup here. There we go. Okay. Okay. All of the liquid out. Let me show you how much liquid there is. Let's see what it says. It's about 25 milliliters. So I'm going to graph that on my observation and results page. Now, if you are not doing this experiment with me, you'll graph my results, okay? If you are doing your own, then you'll graph your results. Now, you might be thinking to yourself, but Mrs. Miller, how can I possibly graph this? It doesn't say 25 milliliters. Can you think of a solution? Let's see, the first box here is for 10 milliliters, so that's 10. This next box marks 20. The next box will mark 30, but that's too far. Well, 25 is halfway between 20 and 30, so how about if we just color it in halfway? That will show us 25 milliliters. Problem solved. All right, the next material that we are going to test is the wax paper. That's what's listed next. So I have my wax paper here. I'm going to dip it into the liquid. I'm going to take it out and let it drip off. Now I see what's happening here. It's sort of similar to like what I see on my car after it rains. It looks like it's beating up. So what does that tell us about wax paper? What can we observe? And what conclusion can we draw from that? Yeah, it's not very absorbent, right? So I don't expect to get a lot of liquid out of this. But let's prove it, because that's what scientists do. So now I'm going to take it and I'm going to squeeze it. Oh, silly me. I forgot to pour this out. Okay, one more time. Okay. Drip. Okay, so now I'll take it and I'm going to squeeze it into the measuring cup. Let's see, got a little bit. Let me show you, can you see here? There's very, very little on the bottom. Definitely doesn't make it to that 25 mark. We have to kind of estimate. I would say it's probably even less than 10. Maybe 5 milliliters. Okay, so let's record that now. Once again, if you're doing this from home, you'll use your own results. If you're not doing this activity on your own and you're just getting your results from me, you'll write down what I write down. So, we have this dilemma again. So we said it's probably not even 10 milliliters. We really had to estimate because my first measuring mark on my measuring cup was at 25 milliliters, and I could see that it was nowhere near that 25 mark. So I would estimate that it maybe absorbed about 5 milliliters worth of liquid. So this first box here is 10 milliliters, right? So 5 milliliters, yeah, it would be about halfway. So let me color it in halfway. Okay. In my hypothesis, I hypothesized that the paper towel would be most absorbent. So that would mean that when I use my sponge, that the sponge would have to absorb less water than the paper towel. Let's see if my hypothesis was correct. It certainly is more absorbent. The paper towel is certainly more absorbent than the wax paper. But is it more absorbent than the sponge? Dun, dun, dun. We're about to find out. All right, here we go. This time I'm not going to forget to pour the liquid, the very little that we have, out of my measuring cup. Okay, here I have a sponge. I'm going to take my sponge, drop it into the liquid, pick it up, let it drip. Still dripping. Let me just give it a few more seconds. Still dripping. And then I'll squeeze it into my measuring cup here once it stops dripping. If you're doing this at home, make sure, and you're doing the same experiment as me, make sure that you let all the liquid drip out before you measure. Okay, because we want to only measure what the object, what the material is able to hold, not what drips out. Once it just about stops dripping, then we can measure. Still going. Okay, so now I'm going to wring this out into my measuring cup. Let's see. Almost got all the water out. Oh, I'm really squeezing this as hard as I can. Oh my goodness. Okay. Now, let's see here. Hold it up. Can you see where it measures? Yeah, it measures up to that 50 line mark, 50 milliliters. So now we'll record those results. All right, so it measured to like exactly the 50 milliliter mark. So now, look here at my observation results. So now I'm going to graph to the 50 line mark, the 50 milliliter line mark. This is 10 milliliters. And notice how I'm not spending a whole lot of time making sure that I color it in perfectly. The idea is just to get the data down on paper. Data is what we call the information that we record when we do an experiment. So that's 40. One more is 50 milliliters. Okay. Now it's time for us to move on to the next part where it says write about 2 things you observed during the experiment. Let me just think out loud. What's one thing I observed? Well, I observed that the wax paper absorbed the least amount of liquid. What's something that you observed? Can you please name 2 things that you observed? Turn and tell the person next to you 2 things that you observed. If you're at home, tell someone in your house or your imaginary lab partner. If you're in school, tell someone sitting next to you. Ready, set, go. All right, 1, 2, 3, eyes on me. So while you were sharing, I was writing down my first observation. I wrote, I observed that the wax paper absorbed the least amount of liquid. Now go ahead and write your 2 observations. You're going to pause the video here, write 2 observations. You need 1 complete sentence for each, and then you can come back and unpause. See you in a minute. Did you write down 2 observations that you made during the experiment? If you did, give yourself a pat on the back. I'll read my second one to you since I already read my first one. My second observation was this. I also observed that the sponge absorbed more liquid than the wax paper and the paper towel. Now, if you haven't finished writing both of your observations, make sure to pause. Finish that before you move on. You can come back when you're done. If you're all finished writing both observations, then we're ready to turn to the back of our lab report. Last page. Okay, so this to me, I think I've told you this before, the best part of a lab report, or the best part of the scientific method to me is the conclusion, because that's where like the real thinking work happens. So conclusion, let's see, first question we need to answer. Was my hypothesis correct? Well, to know that I have to think about what my hypothesis was. My hypothesis was I think the paper towel will be most absorbent. I think this because it is meant to clean up spills. Was my hypothesis correct? Thumbs up, thumbs down. Thumbs down. My hypothesis was not correct. So I would say that. I would say my hypothesis was not correct, period. I thought that the paper towel would be most absorbent, period. However, comma, the sponge was in fact most absorbent, period. That might be what I would write. Now let's see, what did you learn from this experiment? You have to think about that. What did you learn from this experiment? I learned that sponges are very absorbent and will probably be better at cleaning up spills than paper towels. Interesting, right? It's a little bit surprising for me. You'll write down whatever it was that you learned from this experiment. Now, the what if, my absolute favorite part. What if we tried this experiment, but in a slightly different way? What if we changed just one variable, just one part of this experiment? So I could say, what if I repeated this experiment using a washcloth? Or what if I repeated this experiment using a towel? Those could be some what ifs. Think of your own what if. Okay, once you're finished with your conclusion, if there is still time left, you can come back to this video for a read aloud. I have a book that I'm going to read on this very topic of materials that are absorbent and materials that repel. If you don't have time, you can always come back and listen to the read aloud at another time if you'd like. Maybe while you're eating snack, or just if you are thinking like, oh, I just want to learn more about that topic at a later point, you can always come back to listen. I really enjoyed learning with you today. I may be seeing you in a few minutes for a read aloud. If not, I'll see you next time. All right, welcome back. So as mentioned, this read aloud, it's optional. You don't have to do it during this lesson. However, if you're interested in learning more about this topic, feel free to listen to this read aloud. It's called Does It Absorb or Repel Liquid? And you don't have to listen to it right now during the lesson. You can listen to it at a later time. So if you've come back at a later time, welcome back. And I hope you enjoy learning more about this interesting topic. What is matter? All objects are made of matter. Matter takes up space. Matter has mass. Mass is the amount of material in an object. You are made of matter too. We knew that already. What are properties? Matter has properties. Properties describe how something looks, feels, tastes, smells, or sounds. We can hear if something is loud or soft. We can see if something absorbs or soaks up water or if it does not. Absorbency is when an object soaks up water. Absorbency is a property of matter too. Does it absorb liquid? Some objects absorb liquids such as water, juice, or oil. We use a towel to dry our bodies after swimming. A mechanic uses a cloth to clean his hands. What would you use to wipe up a spill in the kitchen? Call it out in 3, 2, 1. I would use a sponge, especially after that experiment that we did where I learned that sponges are more absorbent than paper towels. Gets the job done faster, right? Does it repel liquid? Some objects do not absorb liquid, they repel it. Things that repel water are called waterproof. A raincoat repels liquids. Some placemats repel liquids. You can wipe them clean. Here's our question. What do you wear on your feet when it rains? Do they absorb or repel water? Call it out in 3, 2, 1. Rain boots. Yeah, I wear rain boots. Do you wear rain boots too? Rain boots, or you could also call them galoshes, they repel water. They keep our feet dry. Here's a new vocabulary word for us. Is it porous? Say the word porous. Porous. Very good. Most materials that absorb liquids are porous. Porous materials have tiny openings in them. The openings let in liquid. A sponge is porous. It absorbs liquid. Oh, maybe that's why a sponge absorbs more liquid than a paper towel, because a sponge is more porous. It has these big holes, right? Rubber is not porous. Rubber tires do not absorb water. Paper is porous. It absorbs liquid. On a rainy day, would you carry your lunch in a plastic or paper bag? Why? Whisper your answer into your hands. All right, this is what I was thinking. I said, on a rainy day, I would rather carry my lunch in a plastic bag than a paper bag because I know that plastic repels water where paper absorbs water, and I wouldn't want my lunch to get soggy. Soak it up. Objects change when they absorb water. Some get heavier. Put a dry towel in the washing machine. When it is clean, lift it out. Was it heavier when it was wet or dry? You answer that. Yeah, it's heavier when it's wet, right? Some objects get bigger when they absorb water. Have you ever dropped a book in water? The pages soak up water. So does the cover. Now the book cannot close properly. It might look like this. This happened to me one time. I had a flood in my basement, and I had some books on a low shelf, and all of the books were ruined. They all looked like this. I was not happy about that. Objects that absorb liquid. Objects that absorb liquid help us in many ways. We use them to clean up where we work and live. We use them to keep our bodies clean. We use them to dry off. Or even to blow our nose. It's a good thing that tissues are absorbent. You wouldn't want to blow your nose into something that repels liquid, would you? That would be a snotty mess. Objects that repel liquid. Waterproof objects repel liquids. They protect us from getting wet. They protect many things from getting wet. They also protect things from being ruined. A waterproof rain jacket keeps a dog dry. A plastic apron protects clothes from spills. Here's a question. Does it go on? A duck's body makes oil. Oil repels water. The oil is on the duck's feathers. How do waterproof feathers help ducks? Any ideas? What are you thinking? Whisper into your hand what you're thinking. Okay, this is what I was thinking. Well, the oil that's coating the feathers of a duck helps to waterproof the duck, and that helps the duck because if the feathers absorbed water, the duck might become too heavy and it might not be able to float on top of the water. It might sink. Suck it up. Which objects absorb water? Which do not? Find small objects. You can use coins, buttons, candies, raisins, cotton balls, and seeds. Put them in water. Leave them for a day. Are they different now? Are they heavier? Are they bigger? What happens when you squeeze them? That's a fun activity to try. You could try that on your own. Which clues helped you decide if the object absorbs or repels water? Think about that if you do that activity. Absorb or repel. What have you learned from this book to tell you which objects in each picture absorbs liquid and which repels? Let's see. Let's look at these different objects here. So here we have a sponge and we have a rubber glove. What do you think? What does the sponge do? Yeah, the sponge absorbs water. What about the rubber glove? What do you think that does? That's right, it repels water. That helps to keep our hands dry, right? What about soil? Do you think soil absorbs or repels water? Absorbs, yeah. And that's important because plants need water to survive. So the plant's roots grow into the soil, which absorbs water, and then the roots are able to further absorb the water from the soil, right? And draw it up through there, through the roots, up through the stem. What about a mop? Does a mop absorb or repel water? It absorbs water, right? That's what makes it so good at cleaning our floors. So this I thought was a very interesting read aloud. I hope you enjoyed it as much as I did. And thank you for taking the time to learn even more about this important topic. I'll see you soon. Bye-bye.